Hello again, and welcome to another episode of CISO Tradecraft, the podcast that provides you with the knowledge, insights, and hopefully some wisdom to help you on your career journey as a cybersecurity leader. This is G. Mark Hardy, and I'm pleased to be with you again. And this week, I want to go toward the cloud. I want to talk about cloud infrastructure, and specifically cloud infrastructure drift. Now, what do I mean by that, and why do I think it's important enough to put a whole episode together? If you're moving to the cloud, if you have your resources in that direction, as most of us do at this point, then one of the things we depend upon is having some knowledge of, well, what's up there. And cloud infrastructure drift is a change that occurs in your cloud environment after you've provisioned it. Or another way to say it, it's when the actual state of infrastructure differs from your last defined configuration. Okay, well, yeah, how often is that going to happen? Well, I'll tell you what, according to the accurate State of DevSecOps report, nearly 90% of cloud configurations were modified by privileged users after deployment. Well, maybe somebody documented that, but yeah, I don't know. Those numbers don't sound too good. Plus, last year's Palo Alto's Unit 42 Cloud Threat Report documented over 200,000 GitHub repositories that had insecure configuration options. Now, not all of these were hand-rolled. They may have been reused from an existing configuration option that was already insecure. And therefore, you're getting leverage because you only have to design it once and then reproduce it over and over again. But that's not the type of leverage that helps. It might also explain why nearly 2/3 of cloud incidents are due to customer misconfigurations. All right, numbers again suggesting that we as CISOs need to get ahead of this problem. Now, if you don't have solid version control, the time it takes to respond to a cloud compromise or even a file corruption error goes up significantly. So we have to do a number of things right. First, we have to define a secure configuration. Then need to deploy that configuration repeatedly. And don't forget, ensure it doesn't get changed after being pushed. Now, it doesn't sound all that difficult, but the numbers say otherwise. This year's Palo Alto report states, quote, 30% of organizations globally with publicly accessible cloud data appear to be storing sensitive data. Okay, wait a minute. Did you catch that? Publicly accessible cloud data, sensitive data, 30%. The Register researchers found over 500,000 confidential files exposed in the cloud. So we hear about these data breaches and these cloud breaches, and where organizations lose a whole lot of information, customer data, credit card data, social security numbers, sensitive, etc. Things are bad, and they're maybe worse than bad because, quite honestly, the threat environment is not going to improve all by itself. Now, one idea is to ensure that we can use something called infrastructure as code. And infrastructure as code as a concept essentially means that as a developer writing software, we can produce the same piece of software by just copying the compiled code, right? Same idea with infrastructure as code. If we build a manifest or a recipe and then build a virtual machine or some instance from that point going forward, we expect to get the same type of consistency. Now, one thought is, though, that where do you get these templates? If they come from a public repository, you might want to run it through a full vulnerability scan as part of your continuous integration, continuous delivery, CI/CD pipeline. And in spite of the availability of a lot of these testing tools out there, Unit 42 noted 48% of the Amazon S3 buckets do not have encryption enabled, nor do 41% of Amazon's RDB services. And then to make matters worse, over half of them don't even have logging enabled. Whatever it is we're doing it wrong. So what do we do as CISOs to make it right? If you look at all the modern day principles for DevOps, it's about making everything into infrastructure as code and then automating it. This is a good thing. We can create automated pipelines, deploy instances, deploy containers, deploy whatever we're going to deploy out there in a consistent manner. And we can perform security checks prior to moving code to production to identify code that isn't patched or isn't well configured. And that's a little bit like the security line at the airport. If everybody goes through the same security screening, we can inspect and prevent dangerous things such as weapons getting onto aircraft. But what happens if we allow everybody onto the aircraft without screening and then try to check for it real time while it's in the air? It's kind of the execution checking. You can see that that could collapse as a sound strategy when you had every opportunity to check things on the way in. If we think of AWS, Amazon Web Services, we can see how we can end up in a similar state. Developers there can get access to the AWS command line interface, the CLI, or the console, a GUI version. And they could also use deployment tools like Jenkins or Travis to release software. But if the developer is in the interest of trying to get something up and running, because we're always in a hurry, we got to get it going, use the CLI or the console to make unapproved changes to the environment, and then it doesn't follow the enterprise software checks, what's to keep them from putting bad code into production? It's as if we're going to sell contraband in the airport after everybody's been inspected. And we're seeing this kind of happening more and more. Not the airport stuff, of course, but the stuff in the cloud. Why do we care about it? In May of 2021, the Center for Internet Security released version 8 of their CIS controls. And 20 controls down to 18, a number of things. I'm going to do an episode on that because I think it's important for us to see where the change is. In any case, control number 4 is secure configuration of enterprise assets and software. Now, these are prioritized. That is to say, used to have the basic controls and then do the foundational and things such as that. Well, here, 4 out of 18 is pretty high up there. It's going to be important. And there's a lot of different approaches that could be used in our cloud environment for the secure configuration of these assets. One of them is static security testing. So a lot of commercial and open source tools that will create a static approach to checking your software. Now, static means it's not running. It's just fixed. All right. It has nothing to do with electricity. And typically, these tools will look at a deployment script from something like a Terraform or a CloudFormation and benchmark that against a CIS benchmark for AWS or Azure or Google GCP, which is hundreds of best practices on how to configure correctly within a cloud provider. And the benchmark may say something like all EC2 instances shall utilize encryption at rest. All right, well, then if you have a Terraform file where encryption settings not enabled, you have a finding, and therefore you should probably go fix it. Now, the pros of this is it's, well, a great way of blocking bad things before they come into your environment. It's pretty easy to create new rules and custom rules, and several of these solutions are free or open source, so your cost to implement is fairly low or maybe close to zero. But there are some limitations or cons. If your developers aren't using Terraform or CloudFormation type scripts to deploy your software, that is to say they log into the console and do their lines directly, then the Terraform checks get ignored. Also, the CLI, the command line interface tool, could allow that bypass, and it's out of scope for what's being checked. Also, not all findings that are identified are correct. You have the true positives, the false positives, and things such as that. Some of them can be false positives. Let's say the tool flags because it says, oh, your S3 bucket is public. Warning, danger, Will Robinson. Well, if it's your public website, that could be by design. Now, if it's private data that's in a public S3 bucket, that's a misconfiguration. But these static tools don't have context. They don't know the difference. And therefore, depending on your environment, they could be kind of noisy. Another approach would be to do a runtime inventory. What we'll do is we'll say, hey, let's try to detect misconfigured clouds in a runtime approach. Instead of checking the code in the pipeline, let's see what's actually currently running. And there's tools out there as well that allow us to do things such as that. Some tools Lift cartography will use a graph database, the Neo4j, Network Exploration and Optimization for Java, in case you ever wonder what it stood for, to map out your cloud infrastructure. It allows you to perform database queries on your cloud environment. For example, show me everything that's public facing. Show me anything that isn't encrypted. Show me if I have anything which isn't being logged. That's great and it's useful. But of course, remember, it's already out there running, which means you're spotting issues that are probably already in production. Another tool out there, Dual Labs Cloud Mapper, provides an audit of your cloud environment. It shows you what things you have in each category, as well as a network diagram. Pretty helpful, but if you get hundreds or even thousands of applications in your cloud environment, it's going to get very complex. Another tool, CloudSploit, checks the running infrastructure against the CIS benchmarks and looks for misconfigurations. Now, the pros of doing a runtime inventory approach are what? Shows current risk as compared to the Terraform, which may or may not be what's in the environment. Remember, the first thing, the static look says, hey, it looks like our pipeline's fine, but the problem is you don't know what actually made it to production. Here they're saying, well, we already know what's made it to production. And so that's great. And but on the downside, though, it's a visualization tool, meaning that it's going to catch potential misconfigurations, but now the people running the tools need to understand enough about the environment to know how to fix this and how to make it run correctly and how to improve the errors and correct those. And again, when you're doing a runtime check on a production environment, it's only a single snapshot in time. It doesn't tell you what's going to be there 5 or 10 or 20 minutes later. And although we expect that infrastructure not to change, isn't that sort of the concern here that we've talking about with the cloud infrastructure drift? If you process credit cards, I'm sure you've heard of the PCI DSS, the Payment Card Industry Data Security Standard, and it specifies 12 different security compliance requirements. A couple of them are germane here. Number 6, develop and maintain secure systems and applications. Okay. And then number 11, regularly test security systems and processes. And for example, a detective control that you could potentially use is change detection mechanisms, looking for modifications to critical files. Often could be the operating system if we're talking about OSs, but could also be key applications. Now, in prior versions of PCI DSS, that was limited to the use of file integrity management, or FIM, and commercial tools such as Tripwire was a file integrity management tool for servers, endpoints, and things like that. But in this particular case, an alert is going to go through your incident response process. And then that's going to then determine whether or not we're dealing with an incident. And now we're over an entirely different part of our IT security function. Essentially, we're looking for what's in our cloud. And here we're going to say, oops, we found something. It looks like it's changed. Send off an alert. Let's go and initiate this whole IR process to determine, is it nefarious? Did somebody evil change it? Or was it just one of your developers in a hurry making a quick change at the CLI? I used to work as a developer, and anybody who's done this job knows that the one thing you hate doing more than anything else is, well, documentation. It takes a lot of time, and it's not really moving the code forward. And quite honestly, when you're looking at the code, it's obvious what it's doing. And yet, months later, you come back and try to look at something, and if the documentation's not there, you or somebody else are going to have a devil of a time trying to figure it out, what's happening. And I remember one time years ago, I inherited a code base. I was doing a qualitative risk assessment tool, and the prior programmer had moved on. I got a job there to take over. And I remember he had one subroutine. And by the way, this guy wrote spaghetti code. It was the most unbelievable code. I mean, it ran, but I just could not figure out what was going on. And so I remember I was rewriting it using structured programming language and all the good techniques you're supposed to do that they teach you. But I got to one routine that I just could not figure out. It was sort of the core mathematical engine there. And I remember putting a comment in there that a couple of years later, when my buddy took over, he said, I read your comment. And I said, what was it? I forgot what I wrote. You said, this is an inoperable brain tumor. Well, if you're writing your code to be inoperable brain tumors, where it's only in the mind of the person who wrote it at the time of writing it, good luck maintaining it. And really, what we care about for cloud infrastructure is maintaining this going forward. And if you can't control what goes into your environment, then you really don't have much of a chance of defending it. In the cloud environment, what we're going to be looking at going forward is more and more of our functionality getting away from servers and the like. Some organizations have pretty much pushed everything out where you don't have anything anymore that outsiders are going to come into. I've got one environment that I work in, one of my clients, and guys are saying, hey, you want to buy a VPN? No. Why? Well, then how do your remote workers get in? They don't have anything to get into. I said, what do you mean? I said, I've got software as a service for Microsoft 365. I've got online storage in the cloud. All my functionality is in the cloud. I don't even have a file server or a print server in my environment. Why would anybody need to be able to come in from the outside? It's all in the cloud. And oh, by the way, what does that tell you for a bad guy who somehow might happen to get into my enterprise? How do you do lateral movement when there's nowhere to go to? Now, as we all roll out of COVID and get back into the offices, things are going to change. But if you figured out a way to move your production up to the cloud during either the lockdown or has been part of a general common business practice moving forward, well done. And it's going to continue. And it's going to have more applications, it's going to have more complexity. And if you don't get control over these configurations, they're going to get away from you. And that's how you end up in the news, because something that could have been prevented, could have been detected, could have been done correctly, didn't happen because in the exigency of getting something out the door, we missed it. Now, that kind of begs the question, might there not be a better way to do all this stuff? Do we really have to let this thing grow organically like a garden and then kind of weed it as it goes through? Or can we get it correct the first time? And what we found is that I'd like to go ahead and offer some back and forth with an expert on the subject, somebody who can lend us some insights on what might be different in terms of a better approach. As more and more people work with the cloud, more and more smart people are coming up with great ideas. And I think I got a really great idea for you. Well, today we'd like to share some insights from a vendor that's doing something unique to solve this problem. I'm talking with Yoni Leitersdorf. He's the CEO and founder from Indeni. And Yoni, can you tell us a little bit about Indeni and your solution, CloudRail? I mean, how'd you come up with the idea, and what were the biggest things you saw that needed to change to secure cloud infrastructure?
Sure, happy to. So, in addition to being the CEO of Indeni, I also have the pleasure of being the CISO of Indeni. My background is pretty deep in security, going back a couple decades. And so I got the responsibility for thinking about how to secure our environment. And specifically at Indeni, we have customer data that is stored in our cloud environment. And so it's very important for us to secure that customer data, not only because of our responsibility towards our customers, but also from an audit and compliance perspective. And so when I thought about how to secure a cloud environment, I started looking at cloud security posture management tools, so the CSPM tools. And I was using that to start gaining visibility. So I was using both the tools that were native or are native to the cloud environment, like in our case, AWS GuardDuty and Access Analyzer. But also I was using third-party tools made by other vendors. And as I started playing around with these tools and getting visibility into our environment, I noticed a few things. First of all, I was getting a lot of noise. I was getting a lot of different alerts and different violations that were found by these tools. And I found that I was spending a lot of time trying to narrow down the list. These tools were catching a lot of things that were not real security issues. And so every issue that they were flagging, I needed to actually go and dig deep and investigate and see whether it's a problem or not. And after a lot of painstaking work, I noticed that I could reduce the number of issues by about 90% to just a handful of issues that I actually cared about. And I was really happy about that. And I felt, okay, great. There's a handful of issues here. I know what needs to be done. Let's go ahead and do it. And so I opened Jira tickets for our developers and said, okay, here are security issues, and we need to solve these issues one by one. Let's go through them one by one and solve the problems. And I opened the Jira tickets. I was happy with myself and said, okay, this is going to be done. And soon all of these issues will be gone. But then I noticed that these tickets were taking a long time to solve. You open a ticket and days and sometimes weeks later, they're not yet done. And I was wondering why this was happening. And I realized that at the end of the day, there's a prioritization issue and a cost issue with each of these tickets. So, first of all, from a prioritization perspective, security is always a high level priority, but in businesses, there's always a higher priority, and the higher priority is progressing the business. So, building the features that the users need, making sure that you're supporting them, fixing bugs, et cetera, et cetera. So, you're very focused on delivering the service that your customers need. And so, those types of issues tend to get a higher priority than security issues when you think about it from a software development, and engineering perspective. So that was one issue with why these tickets were not moving forward. The second issue was that fixing each and every one of these tickets, completing these tickets, was actually very costly and time intensive. So if you think about something as simple as wanting to change a setting on a database in the cloud, you think, okay, it's just a field, So if I want to turn on some kind of feature on AWS RDS, then it's just a matter of turning on that feature, changing the field, and everything's good to go. But in many of these features, what you learn is that to make that change, to make that update, you need to rebuild the database. So, for example, if you want to enable encryption at rest in a database, you need to take a backup, rebuild a database with that feature turned on, and then restore from a backup. So, fixing something as simple as a flag can take hours, if not days, and actually include a maintenance window and an outage and a lot of frustration. And so, we are having two problems with resolving these Jira tickets: the priority and the amount of time that it was taking. And as I looked at it, I said, okay, this is crazy. You can never really solve problems this way, because if you keep finding issues in production using cloud security posture management tools and concepts, nobody's ever going to fix them. These things are going to kind of die on the vine, and the security issues are going to remain. So it doesn't make sense to keep going on this way. And so, as I was digging into this, and together with the team, it wasn't just me, of course, we started looking at what are other ways for identifying and resolving security issues. And as we were going through that, we saw that there's a new opportunity in the market. And that opportunity is what a lot of people call shift left. But basically, the idea of finding cloud security issues much earlier in the process. So instead of finding a cloud security issue once your cloud environment is in production, your application is in production and running, there is a possibility of finding cloud security issues much, much, much earlier in the development stage. And the way that works is that today, instead of just building cloud environments using point and click in the cloud environments console or portal, people are starting to shift to something called infrastructure as code. Infrastructure as code is a way to describe your cloud environment using code. And there are a lot of languages for doing that today. You've got Terraform, you've got CloudFormation, Pulumi, AWS CDK, et cetera, et cetera. So there are different ways to describe your infrastructure today in code. But the idea is that you're describing the infrastructure in a set of files, And then a tool goes and uses those files to build the environment that you want. So, for example, you can use Terraform to describe the network that you want, the compute resources, the storage, everything else. You can describe all of that in infrastructure as code. And that's really cool for building cloud environments and makes cloud environment building a much better process, a much more controlled process. But one of the huge advantages of it is that it now allows us to actually do cloud security analysis on the code. So we can actually look at Terraform or CloudFormation and see what is going to be built, and then actually do the security analysis on that code and identify problems. And what this does is it reduces the amount of time and effort required to solve any cloud security issue by at least a factor of 10, if not more. So if we go back to the example I gave earlier about changing an RDS database and turning on encryption at rest there, if you're doing it in infrastructure as code, all you need to do is change one line. You change one
Wow.
line, you push
Yeah.
the code, and that's it.
So really what it sounds like is the main advantage here is instead of trying to work on systems in production, at which point they've got to do all this backup and redo and everything else and redo, you're actually going to take a look at the infrastructure as code templates and focus our effort there, which to me seems a little bit unique in the space. We are shifting left, and that makes good sense. But how does this help lower the cyber risks for companies when they're doing this?
That's a great question. So, if you find cloud security issues and you don't solve them, then you're not really reducing your risk. And that's what's happening a lot today if people are looking at the production side. By looking for issues when things are still being developed on the shift left side within DevOps pipelines, then you're actually solving issues. And as a result, you can drastically reduce your risk. And I would even be as bold to say that 5 years from now, I anticipate over 90% of cloud security issues that get resolved, they will be resolved within the pipeline. They will be resolved on the left side and not in production, because that's just what makes sense. Nothing else makes sense. No other alternative. And so we're going to see much more secure cloud environments in over the next few years, but that is going to be because organizations will adopt shift left and will actually solve cloud security issues in development before they get to production.
Got that. So it sounds like a good cost savings in terms of a lot of saved work, a lot of saved kind of rework and things such as that.
Mhm.
Is that the biggest gain from the perspective of cost? Is there something a little bit better than that in terms of assurances or the like for people who use this approach?
Yeah, so in addition to actually having a much more secure cloud environment, it also does one more organizational thing that is really interesting to observe. So we over the past few decades, we've seen the software developer side of the house at odds with the security side. So the way it worked was the software developers were developing their application, trying to run as fast as they could, and then security comes at the end of it and puts the brakes and says, you got to stop. We need to do a security review, and we found 17 different issues, and now you need to go and fix every one of them. And so software developers didn't really like security people, and security people thought that software developers were reckless. And from an organizational perspective, that's not a good place to be in. And so the interesting thing about shifting left and moving security checks into the development process is that developers become more security conscious and they start respecting the work of security and what needs to be done there a lot more. And then the security side of the house, they begin understanding development a lot more and understand the metrics that developers use, the processes that developers use, the need for developers to be fast and push often. And so, beyond the cost and the massive cloud security value that this brings, it brings organizational value and people get closer together. And as a result, not only are they happier, but they can do much better things for the organization. Applications can come out more secure, they can come out faster, the teams will collaborate more, and the results are going to be better. And so there's an organizational value here too.
Yeah, so it sounds like it's a kind of a real win in the DevSecOps world where we're
Mhm.
injecting that security in there. But more than that, It's not just kind of paying lip service to say, hey, let's just go ahead and shift everything left. What we're actually doing is generating some real improvements that take place throughout the entire cycle, where, as you had said, developers start thinking a little bit differently, security folks think a little bit differently, and hopefully they think they are on the same team.
Yeah.
Yeah, which is really kind of a real accomplishment in some cultures. But once you get there, and it's awesome.
Yeah.
Now, if someone want to implement this, he said, hey, I love this idea, I want to make this happen. How long is it going to take to be able to get that into place? Is it stick disk one into drive A and secure your CI/CD pipeline, or is there a little bit more complicated than that? How does someone go about doing this?
Yeah, so it's a process, it's a transition. So first of all, you need to be adopting infrastructure as code. And today, we see most of the adoption of infrastructure as code being in technology companies. So those who may have been startups in the past and have grown since then, or have been technology companies for a while. And also, we see the adoption of infrastructure as code in companies that have been around for for decades, but have decided to invest a lot into technology. So, the adoption of infrastructure as code is still nascent, but is going to cross the chasm and become commonplace in the next few years. But it is important to first adopt infrastructure as code. Once you've adopted that and you've built your CI and CD processes around infrastructure as code, then you're ready to do shift left, to do real shift left. You can't do it before that. And once you're at that point, then you have a bunch of different tools that you can choose from. So if you think about it, you have application code. And so there's a bunch of tools around securing application code. You've got infrastructure code, which is what we're kind of focused on in this conversation. And so there's a bunch of different tools for doing that. You also have containers, and you have other things that each of them have tools for doing security once you've built your CI/CD process around this. Here in the infrastructure as code space, the different security tools that have been around over the past year and a half or so were very new to the market. They were the first offerings for doing security and infrastructure as code, and we actually looked at them and we actually started using them. But we found that they were a bit naive. So since there was nothing before them, then they could just go forward and start with something very basic from a security analysis perspective. So, for example, they would look at your code and say, look at a specific resource and look at the specific fields of that resource. And if a specific field is not set the way that they want, then they would alert you about it and stop your pipeline. And the problem with this is that if you start stopping the pipeline too often for too many issues because of noise or whatever analysis that you're doing, developers will get very frustrated. So we all know about the story of the boy who cried wolf, and at some point, the village no longer wanted to help the boy. In the world of stopping pipelines, it can get even much worse than that, in the sense that if you start stopping the pipeline for a lot of issues, and many of them are either minor or not interesting or not even a problem, developers will get frustrated. And the reason is that developers, they're focused on moving forward, always moving forward. They get a ticket, they want to get it done, commit the code, complete the pull request, push it through, and then move on to the next one. That is how they think about the world. And so if you keep stopping them in their tracks and telling them, oh, hold on, your code is not okay, you need to fix this, you need to fix that, they will get very frustrated. And at some point, they will try to get the tool out of the pipeline. So they'll go back and say, you know what, this whole idea of shifting left was very nice, but it's driving us crazy. And therefore, we want the tool out of our pipeline because it's making our lives very difficult. And so the initial tools were kind of naive in that perspective. They were finding a lot of issues, but most of them basic, driving developers crazy at some point. And so when we were looking at that, we thought, okay, there must be a better way to build this. So we've looked at the CSPM tools. We decided we want to shift left. We looked at the infrastructure as code security tools in order to shift left, but they were naive and they were noisy, and there's nothing better out there. So we said, well, we're a tech company, we're a software company, and we know how to build stuff like this. So let's go ahead and solve the problem ourselves. And so we just decided to build the product. We decided to build CloudRail because we had a need and we saw that it wasn't met by existing tools and existing offerings. And we built it. And the idea behind CloudRail is to say shift left is the future. Let's figure out a way to do it in a manner that doesn't drive developers crazy and developers will actually embrace and developers will actually like and love. And if we can do that, then the dream of having more secure cloud environments can actually be achieved because developers will cooperate with this tool and you'll have a more secure environment. And that's the big thing about CloudRail. It's how do we get security in there an inch at a time, a step at a time, in a way that developers are happy with it, but also the security side is happy because things are actually getting much better. And that's a huge focus for CloudRail.
Yeah, and it seems like a real improvement because if you go back and look at, let's say, physical manufacturing and like automobiles, you make a car and at the very end you inspect it and then you got a recall and things like that. And one of the things that Toyota really pioneered was the end-on cord, which basically everybody could go ahead and pull a cord and stop the production line and said, hey, wait a minute, there's a defect. And the culture there wasn't, hey, you're going to get yelled at for stopping the production line. It's a bunch of guys who run down with lab coats and clipboards and like, no, fix it, because everybody owned the quality. But of course, the problem is that the whole production line stopped. And what looks like you've done one better than that is to be able to then have this where we're essentially building it in at the front end so that by the time you get to production, you don't see these errors. That cord's, if you will, just kind of growing a little bit of cobwebs because no one's had to pull it in a long time because you did it right. You did it, well, actually, say you did it left would probably be a better way to look at it.
Yes.
and get up like, yeah, we are left. And like, so got it. So organizations that want to do this say, okay, fine, this is really cool. I like this. But if they have kind of unique cloud needs and things like that, are they out of luck? Does this only work in one particular cloud environment, or is this something that's flexible that could work in multiple places?
Yeah, so eventually it's going to work in all cloud environments and all languages. So if you think about it, you've got a few major cloud players out there, and you've got multiple different coding languages that you can use to devise your infrastructure. And so what we've had to do is actually teach our product to understand the different cloud environments. And today we support AWS and Azure, but we're going to be supporting GCP soon as well, and then other cloud environments. And so there is quite a bit of work that needs to be done in order to teach the tool how each of these environments work and how to do the analysis in these environments. And maybe soon I'll also get into how the inner workings of the tool work. But the obvious future is that people are going to be using different cloud environments. Some people use multiple cloud environments for a variety of different needs. And so any tool that wants to be useful in this kind of market has to support all of them. And with CloudRail, you're going to see that very soon. And so whatever cloud environment, whatever language or coding language you're going to be using, you'll be able to use CloudRail for it. And on top of that, you're also going to be able to customize CloudRail. So you can write your own rules, for example, and that way you can actually adapt the tool towards your needs, your environment, your requirements, your controls, and that makes sure you get the most value out of the concept.
Wow, I mean this is fascinating, and I think this is really cool. I mean, I enjoyed this immensely, and hope everybody else listening in did as well. Any last thoughts or any ideas that you want to share before we wrap up for the day?
Yeah. So when you think about how to do something like this, there are two main concepts. One is called static analysis, and the other one is called dynamic analysis. In the world of application security, it was called SAST and DAST, but here we're calling it static analysis and dynamic analysis. And just to explain the difference between them, static analysis basically just looks at your code. Dynamic analysis looks at both your code and your live cloud environment. So, if to give you an example, Let's say your code wants to spin up a database in some kind of subnet, and it only describes the database and it refers to the subnet by ID. So static analysis will just look at the database and that's it, because that's all it can see. It's just looking at the code. Dynamic analysis will actually look at your live cloud environment and understand where that subnet is defined, what VPC it is it a part of, is it connected to the internet, what's its routing table, who has permissions to the subnet from an IAM perspective, et cetera, et cetera. And so dynamic analysis gives you much more precise results, a lot less noise, but also actually finds the really important issues. So as we talked about earlier, we want to make sure we don't interrupt the pipeline too often, just like the production line at Toyota. And so in order to really deliver on the future of shifting left and infrastructure as code, dynamic analysis is what's needed. And we built that directly into CloudRail. And we're starting to see this also with some of the other tools started moving towards the dynamic analysis side of things. But it's really amazing to see the results you can get from dynamic analysis. You can get very, very precise identifications of issues. You can get very precise remediation steps, etc. And that way you're only fixing the things that matter. You're only spending your time on the things that matter. And that's a huge thing for organizations. So I think as people think about shifting left and as they're looking at different technologies for doing that, you'd want to look at those technologies closely and see, do these technologies have a strong understanding of the environment? Are they taking multiple different data points instead of just looking at the code? And if they are, then it's the resulting value to you is going to be far, far greater than just doing static analysis. So that's maybe a kind of a last point for people to think about.
Well, sounds good. Hey, Yoni, thank you so very, very much. I mean, I got to love the fact that you're both the CEO and the CISO. And that gives hope to a lot of listeners say, yeah, but you want to be the CEO, start your own business. As any entrepreneur will tell you, that's probably one of the scariest things to do. It's, I've started a couple, and of course, you've done this and been successful. And as everybody says, you got like a 90% chance of failure. Well, you know what? If you don't try, you got a 100% chance of failure.
Yep.
So at least take a swing at the plate and keep going. So best of luck and best wishes for you for building this really cool capability that I think folks are going to find incredibly valuable. So thank you for being on the call here from Indeni, and we're looking forward to seeing great things from you and your business. So wrapping it up here, G. Mark Hardy here for CISO Tradecraft. Hey, thank you everybody for tuning in. And remember, you can follow us on LinkedIn or share your connections with others. Let everybody know where you're getting all these great ideas for your career. Until next time, stay safe out there.